Good morning to one and all present here. I am Mr. K. Balasan, Assistant Professor, Department of Electronics and Communication Engineering, Sri Venkateswara High Tech Engineering College, Gobi. Today we discuss about the topic Internet of Things. What is IoT? The Internet of Things is the network of physical objects or things embedded with electronic software, sensors and network connectivity which enables these objects to collect and exchange data, allows object to the sensed and controlled remotely across existing network infrastructure, creating opportunities for more direct integration between the physical world and computer-based systems, and resulting in improved efficiency, accuracy and economic benefit. Things in the IoT sense can refer to a wide variety of devices such as heart monitoring implants, biochips transponders on farm animals, electric cams in coastal waters, automobiles with built-in sensors, DNA analysis devices for environmental or food monitoring, or field operation devices that assist firefighters in search and rescue operations. These devices collect useful data with the help of various existing technologies and then autonomously flow the data between other devices. IoT refers to a network of physical devices, vehicles, appliances, and other objects embedded with sensors, software, and connectivity that allows them to collect and exchange data over the internet. Features of IoT: connectivity, automation, data collection and analysis, remote monitoring and control. Connectivity: devices communicate with each other and cloud platforms via the internet. Automation: IoT enables smart automation by allowing devices to perform tasks without human intervention. Data collection and analysis: sensors collect real-time data which can be analyzed for better decision making. Remote monitoring and control: users can monitor and control IoT devices from anywhere using apps or web interfaces. IoT applications: smart homes, smart thermostats, security cameras and voice assistants, wearable devices, smart watches and fitness trackers that monitor health metrics. Industrial IoT: smart factories use IoT for predictive maintenance and automation. Healthcare: remote patient monitoring and smart medical devices. Cities: smart traffic lights, waste management systems and connected public transport. Where are we now in 2021 to 2024? From 2021 to 2024, IoT has rapidly evolved, integrating AI, 5G and edge computing to enable smarter and more efficient applications across industries. Here an overview of key development during this period. IoT growth and adoption. Increases in IoT devices. The number of IoT devices has exceeded 15 billion plus globally. 5G deployment, fastest and more reliable connectivity has boosted real-time IoT applications. Smart homes and wearable. More households adopted IoT-enabled security systems and smart thermostats and fitness trackers. Advancements in IoT. AI plus IoT. AI-driven IoT systems improved automation, predictive maintenance and data analysis. Edge computing. Devices process data closer to the sources, reducing latency and reliance on cloud computing. Security enhancements. Stronger IoT cyber security measures were implemented to prevent hacking risks. Industry-specific IoT growth. Healthcare, telemedicine, remote patient monitoring and AI-driven diagnostics saw widespread use. Smart cities, IoT-powered traffic control, waste management and energy-efficient lighting expanded. Industrial IoT, Factories adopted predictive maintenance, robotics, and automation for efficiency. Agriculture. Smart sensors for precision farming and automated irrigation improved crop yield. Challenges in IoT 2021 to 2024. Security concerns, hacking threats, and data privacy issues remained a challenge. Device interoperability, lack of standardization made it difficult for different IoT devices to work together. Energy consumption, powering billions of devices efficiently is still a concern. Next, IoT ecosystem. Ecosystem components, device manufacturers, sensors, actuators, smart appliances, network service providers, operators, NMS providers, cloud service providers, data centers, database, data warehouse, platform providers, middleware providers, SDKs, third party applications, developers, analytics providers, tools, APIs. IoT ecosystem components and how it works. The IoT ecosystem consists of interconnected components that work together to collect, process, and utilize data from smart devices. It includes hardware, software, connectivity, data processing, and user interfaces. IoT devices and sensors. Hardware. These are the typical object that collects and transmit data. Example, smart thermostats, wearable devices, industrial sensors. Thermostats. Next, wearable devices, Fitbit, Apple Watch, industrial sensors, temperature, humidity, and motion. Connectivity and communication. IoT devices need a communication network to transfer data. Common IoT connectivity methods: Wi-Fi, Bluetooth, 5G or 4G, LoRaWAN. IoT devices need a communication network to transfer data. Wi-Fi, high-speed home office networks. Bluetooth, short-range device communication. 5G or 4G, fast or wide area connectivity. LoRaWAN, low-power, long-range networks for industrial and agricultural use. Edge computing and data processing. Instead of sending all data to the cloud, some data is processed at the edge. Examples, smart cameras that analyze videos footage before sending important clips to the cloud. IoT enabled industrial robots that make real-time adjustments. Next, cloud computing and data storage. IoT data is stored and analyzed in cloud platform like AWS IoT Core, Microsoft Azure IoT Hub, Google Cloud IoT. Cloud system enable large-scale data analysis, AI integration, and decision making. IoT applications and user interfaces. IoT users interact with devices through applications, dashboards, and APIs. Examples, smart home apps, industrial monitoring dashboards, wearable health tracking apps. Example, General Electric deploys sensors in its jet engines, turbines, and wind farms. By analyzing data in real time, GE saves time and money associated with predictive maintenance. Broad research directions. Hardware. Before 2010, RFID tags and some sensors built into mobile devices, NFC in mobile phones, smaller and cheaper MEMS technology. 2010 to 2015, multi-protocol, multi-standards readers, more sensors and actuators, secure low-cost tags. Example, silent tags. 2015 to 2020, smart sensors. Example, biomedical, more sensors and actuators, tiny sensors. Beyond 2020, nanotechnology and new materials. Data processing, serial data processing, parallel data processing, quality of services. energy frequency spectrum aware data processing context adaptable. 2015 to 2020 context aware data processing and data response. Beyond 2020 cognitive processing and optimization. It is evolving rapidly, driven by advancements in AI, 5G, edge computing, cybersecurity, and sustainability. Research in IoT spans multiple domains, from hardware improvements to AI driven analytics. Edge computing and AI driven reduce latency and improve real time decision making. AI powered edge devices for local data processing, federated learning for distributed AI models, reducing power consumption in edge AI chips. Application smart cities, autonomous vehicles, industrial automation. IoT security and privacy strengthen protection against cyber threats. Blockchain based IoT security for decentralized authentication, zero trust architecture to prevent unauthorized access, lightweight cryptography for resource constrained IoT devices. Some applications: smart homes, healthcare, industrial IoT, sustainable and green IoT. Develop energy efficient and eco friendly IoT systems. Energy harvesting IoT sensors, solar, kinetic, RF energy. Low power consumption protocol, LoRaWAN, NP IoT. E waste reduction through biodegradable IoT components. Some applications: environmental monitoring, smart agriculture, green buildings. 6G and next generation of IoT connectivity enable ultra fast or low latency IoT communications. 6G integration with IoT for ultra high speed data transfer, terahertz communication for IoT networks, satellite IoT for global connectivity in remote areas. Some applications: smart cities, autonomous drones, global supply chains. Digital twin and industrial IoT improve industrial automation and predictive maintenance. AI powered digital twins for real time simulation of physical assets, predictive maintenance using IoT plus ML models. Human in the loop IoT for collaborative robotics. Applications: smart factories, logistics, oil and gas industry. IoT as a network of networks, transport, energy, other, earth, home, education, business. Individual networks connected together with security, analytics, and management. These networks connected with adapted security, analytics, and management capabilities. This will allow to IoT become even more powerful in what it can help people achieve. The Internet of Things is often described as a network of networks because it connects multiple independent networks such as smart homes, industrial systems, healthcare devices, and smart cities into a larger interconnected ecosystem. Interconnected systems IoT is not a single monolithic network but a combination of various sub-networks. Example: smart home networks, industrial IoT, healthcare IoT. These networks use different communication protocols but interact to smart home networks, smart thermostat, security cameras, voice assistants. Protocols: Wi-Fi, Zigbee, Bluetooth. Interaction: connected to cloud services like Google Home and Alexa. Industrial IoT networks, devices, predictive maintenance sensors, factory robots. Protocols: 5G, LoRaWAN, OPC UA. integrated with supply chain and logistics systems. Knowledge management. uh, Benefits of humanity, less important to more important. Wisdom, understanding, knowledge, information, data. The more data that is created, the better understanding and wisdom people can obtain. Wisdom, evaluated understanding, appreciation of why. Knowledge, answers to how questions. Information, answers to who, what, where, when questions. Data, simples. Knowledge, creations and capture. The IoT sensors devices generate vast amounts of raw data. AI extracts patterns and insights from unstructured IoT data.